Okay, today my talk is about how to stop designing mouldy buildings, and I really believe that mainstreaming the thermal bridge is part of the means of doing that. This is part one of a talk that I gave at the NZEB 15 conference in DIT in Dublin on the 29th of May 2015. Part two will follow in a separate video. I just want to talk about the technical guidance document to Part L 2011. In section D2, it defines the means of designing buildings which are not going to produce mould and that are going to avoid surface condensation. And the key factor used in assessing the risk of surface condensation is the temperature factor, the FRSI as it's known. Now, in determining that for dwellings, an FRSI value of 0.75 or greater is required to ensure that the risk of mould growth is contained. It's a simple matter of complying with the formula included in the document. The FRSI is calculated by reference to 4 temperature values. TSI is the temperature of the internal surface. TE is the temperature of the external ambient air. TI is the temperature of the room internal. And TE again is the external ambient temperature. Now, given that in calculating these values, we use default values for the internal and external temperatures of 20 degrees on the inside of the building and 0 degrees on the outside of the building. So once we plug those values into the formula, we can be sure that if the FRSI is to be above 0.75, the temperature of the internal surface anywhere in the building must not be less than 15 degrees C. So TSI has to be greater than 15 degrees C. That is the test for whether your building has been designed in compliance with the building regulations for surface condensation risk. You'll notice in that formula there is no reference at all to ventilation. Ventilation is completely irrelevant when deciding whether a building has been designed to avoid surface condensation and mould growth. Ventilation only becomes a factor if the building has been designed in accordance with FRSI and still produces mould growth. Then the use of the building by the occupant becomes a factor, but that's not a design issue, that's a use issue. So very important to decouple the notion of ventilation from the notion of design to avoid mould growth and surface condensation. The calculation procedures are laid down in 3 different documents. BRE IP 1-06 gives the basic method of assessing the thermal bridging at junctions and around openings. That uses ISO 10211 to define the means of calculating the surface temperatures, which in turn refers to ISO 13788 for the surface resistance to be applied in that calculation. Now, that last document was harmonized on the 3rd of December 2013, and from that date on, a very significant change was made to the Irish building regulations, which has fairly dramatic effects on the way we calculate these and what's allowable. And it comes down to this section of 13788, which is 4.4, the surface resistances to be applied in the modelling. The external surface resistance of 0.04 is not an issue. That didn't change. It was the same before December 2013 as after. But what did change was this internal surface resistance to be applied in the modelling. And it changed to take account of the effect of corners where there's less airflow, be furniture which restricts airflow, curtains, which again restrict airflow, or suspended ceilings, which again reduce the amount of air flowing over the surface, and therefore are likely to induce surface condensation by virtue of the fact that there isn't the same level of washing of the surface with ventilation to raise the temperature slightly. So this 0.25 factor was introduced, which is significantly more difficult to comply with than the previous factors, which are shown in Table 2. So where previously upward heat flow attracted 0.1 surface resistance, it's now 0.25. Similarly, for horizontal out through the wall, it went from 0.13 to 0.25, and then the downwards element went from 0.17 down again to 0.25. So these have had a profound effect on the way we go about the calculation of FRSI and the potential for mould growth on the interior surface of buildings. And an example of that is ACD 1.15, which is a ceiling meeting a gable wall in cavity wall construction, where the insulation is at ceiling level and the cavity is a full fill, or it doesn't have to be, but the significant thing is that the insulation in the cavity extends up above the surface, the top surface of the insulation in the attic space. 250 millimeters is required as a minimum in the ACD. This one, when we apply the old surface temperature factors, surface resistances of 0.1 and 0.13, passes the FRSI. You can see it's got a temperature of 15.49 at the joint between the ceiling and the wall, and this is equivalent to an FRSI of 0.77, which is greater than 0.75, so that complies. When we take the same detail and apply the new surface resistances, internal surface resistances of 0.25 to the ceiling and the wall, we get a very different picture. In this case, the minimum surface temperature in the corner of the junction is 13.79, which is less than 15 degrees, our minimum threshold for compliance. Therefore, the FRSI at 0.69 is less than the 0.75 required by the Irish building regulations. So we've gone from a situation where the same detail, the same ACD 1.15 was compliant before December 2013, but actually not compliant after 2013 because of the harmonisation of 13788. Now, if we look at that junction in 3 dimensions, we also get another problem. If we look at ACD 109, which is where the eaves meets the gable wall, and we're going to consider that junction in 3 dimensions using the strict compliance with the ACDs for this. And actually, here's an example of one under construction in Dublin in the last few weeks. And you can see it's very standard construction. It's 100mm cavity block wall with a full fill cavity insulation. In this case, it's a phenolic foam, and that's the completed detail before the roof was applied. So you can see a very standard construction cavity wall. Both the wall at the front and the gable wall, and in this case the gable wall is fully insulated all the way up to the eaves because the room inside is going to be converted for use at some point. Timber roof, cut timber roof, very simple. When we model that junction up in 3 dimensions in Sci-Therm, the basic components are all modelled in 3 dimensions, and we notice that actually the surface temperature factor fails the FRSI test. 13.47 is significantly lower than is required to meet the building regulations requirement. So that detail using both ACDs is non-compliant after the regulation change, the harmonisation of 13788. Now, we looked at a number of different ways of modifying that ACD to make it comply In this case, probably the simplest way is to use a lightweight block in place of the existing blockwork on the inner leaf only. But it turns out that you need to use 2.5 blocks, and in this particular arrangement at these points immediately behind the wall plate. And you also need to put a block of insulation above the wall plate to close off any gap at that point. And in this case, when we run the calculation, we just barely pass the FRSI with all those thermalite blocks or quinolote blocks and with the insulation above the wall plate. So I've detailed all the compliance criteria here, so if anybody wants to check my modelling and produce the same result, they can do so. All of the resistances and the various cavity sizes and blockwork sizes are all listed in the specification here. So what does the responsible educator do when we find that the ACDs don't comply? Well, we go back to the standards, of course, and check that we're right and we've not misinterpreted anything. We revise our syllabus on 2 courses now to ensure that students know that there is an issue and they have to be very careful about how they calculate these things. We warn our previous graduates from the course that there is an issue and that they need to adjust their understanding of the regulations. We advise the regulators, we advise the Institute of the Architects of Ireland. We issued 3 blog postings on the B-Regs forum, which is the most read forum on discussing these matters. We tweeted about it on social media, and we asked the Minister for clarification. So as responsible educators, we've done all of these things in order to make sure that we're understanding the requirements of the building regulations correctly and disseminating that properly to our students. The issue really comes down to that paragraph 4.4.1, which is about the increase in the surface resistance factor 2.25. And when it applies and how it should be applied. So we saw clarification from the Minister. And happy to say that the Minister accepted the question and was clear that he wished to answer it. He addressed it as, I referred to the question number 788 of the 15th of April, which addresses the approach to calculating the temperature factor in the vicinity of thermal bridges at junctions and around openings in accordance with Appendix D of the Technical Guidance Document L 2011, which is great. That means he understands the question and he is about to answer it in accordance with our seeking of clarification. His response then goes on to say, a surface resistance value of 0.25 is only used in very specific situations as outlined in section 4.4 of ISO 13788, which is of rather limited relevance in this context and for that reason has not been referenced at Appendix D of TGTL 2011 or referred to in the reply to question 788 of the 15th of April 2015. Now we kind of find that difficult to understand, so decided to apply it to a particular wall in a residential building. So this is standard residential building, one external wall in this room with a window in it, and now we're going to try and apply the logic of the Minister's argument to that wall to see if it is of rather limited relevance in this context. So the first thing to do is to check for the main issues that if we read that correctly, if we read the Minister's statement correctly, then by excluding the corners, we would exclude those areas in yellow in this particular case. By excluding the curtains, we would exclude those areas in yellow on the diagram, and by excluding furniture we would exclude the area in red, which is the only remaining part of the wall where you're likely to put furniture up against that wall. So we're now at the point of seeing that actually in that room 100% of the wall surface is governed by the requirements to calculate it in relation to corners, furniture, curtains. So actually that's not of rather limited relevance, but it's actually 100% relevant to that particular wall. Now we rack our brains and wonder if there's any point in an external wall in a residential building which won't qualify either as somewhere somebody might put some furniture up against, be a corner, or be an area where people might put curtains on a window. And when you take all of those together, actually the requirement of the standard is that you should just apply the 0.25 generally. There is no get out clause. 0.25 is the requirement, and it's clear from this example why that should be the case. So we're now left in the quandary of wondering if it's possible for the design certifier to use the ACDs to deliver a mold-free compliant design in accordance with the requirements of the TGDL Part D. And I'm afraid to say that our conclusion is that it is significantly less than certain that the designer can rely on the ACDs to deliver a compliant building. The wording of certainty is a reference back to SI 9 of 2014, which is the BCAR regulation requiring that the design certifier certifies that the building is compliant with building regulations. This is a statement that they are certain that it does comply with those regulations. And we've seen that if the design is reliant on the ACDs, that statement is not true. The designer cannot be certain that the building is compliant with building regulations for surface temperature factor or condensation, surface condensation risk. In part 2, I will go on to examine what the implications of that finding are on our work in DIT in 2015. Thank you.